Everyone. So you guys voted for atomic theory as a review, so here's a little mini lesson for you. I want you to watch the mini lesson, and then there's a discussion post that I would like you to complete. All right, the first thing I would like you to do is take 30 seconds and on your paper list as many terms, say hi Phoebes, list as many terms that you can think of related to atomic theory. So I'm going to give you 30 seconds, brain dump, write the whole time or draw little sketches the whole time. Ready, go. Fifteen more seconds. 5, 4, 3, 2, 1. Put your pencil down. So hopefully you came up with some things. Maybe you mentioned that there were positively charged protons, so the word protons, in the nucleus with some neutrons. So we have proton, we have neutron, both in the nucleus. Maybe you drew something like this with electrons orbiting that nucleus. So electron would be a word. There's my electrons. So what I just drew here, this is called the Bohr model. And that's the same as your kind of Jimmy Neutron or Big Bang Theory model, just drawn in 2D where the electrons orbit the nucleus. That's the most common visual for the atom. Most people see it like this or like this. But the reality is there is a better model. It's called the quantum mechanical model. And so that's where we have this nucleus. And then we have a nice, I need like the highlighter, a nice cloud of electrons, and there's different shaped clouds of electrons that we might see. There's the P-shaped and the S-shaped. So we have these high probability regions of finding electrons called the electron cloud. That's actually the most accurate representation of the atom that we know of. So let's go through each of these and state where they are located in the atom. So the proton is, we just said, in the nucleus. The neutron is in the nucleus. And the electron is in the electron cloud. Let's do function. So the protons we know have a positive charge and a mass of 1 AMU. The neutrons are neutral in charge and have a mass of 1 AMU. And the electrons have negative charge and mass is negligible. They do have mass, but it's not enough for us to really pay attention to, because compared to the proton and the neutron mass, it's so small. So we know that proton plus neutron will give us our mass number. We know that the number of protons is the same as the atomic number. And we know that protons minus the electrons is going to give us our charge. So if we change electrons, we're going to get ions. If we change neutrons, that's going to give us isotopes. If we change the protons, it's going to change the element. So one of the biggest mistakes I see in AP Chem is kids using these two words incorrectly, isotope and ion. So isotopes are atoms with the same number of protons, so the same element, carbon and carbon, but different numbers of neutrons, which means they have a different mass. Whereas ions are single atoms or groups of atoms. Those are called polyatomic ions. And they have an overall positive or negative charge because they either gained electrons, making them negative, or they lost electrons, making them positive. So here's a little challenge for you based off these definitions. It will not work with our table because you're sitting at home. I would like you to come up with a metaphor or an analogy to help someone remember the difference between isotopes and ions. See what you can come up with. The more creative, the better to help you remember the difference. So let's dive a little deeper into isotopes. How do we name them? Well, an official isotope name will be the element name, dash, and then we'll put the mass number. So for example, we have the isotope carbon-12 and the isotope carbon-13. How do we write the symbol then? So that's the isotope name. The isotope symbol is going to be the element symbol. There'll be a number here and a number here. I should not use the same thing. There's lots of letters in the alphabet Butler. Okay, let's try this. So this is going to be your element symbol. This guy is going to be your mass number, protons plus neutrons, and this is going to be your atomic number. So something like 12 carbon, and carbon's number of protons is 6, or 13 carbon, and then 6 protons. Do isotopes affect the properties or size of the element? Well, we know that the mass number is impacted because we have more neutrons or less neutrons, but it does not impact the properties so it doesn't impact the element properties or how it will react. So if I had a handful of carbon, you would not be able to tell based off what it looks like or how it reacts if it's carbon-12 or carbon-13. So we would say does not impact properties or reactions. And then let me just put a little disclaimer, except nuclear reactions. So if we're talking nuclear decay or anything like that, then the type of isotope would make a difference. All right, how do we name ions? What we're going to do is if it's a negative ion, which is called a cation, we're going to drop the ending and add "-ide", and that's only for negative ions. So this is chlorine, this is chloride. If it's something that's positive, like calcium versus calcium 2+, we would just say calcium ion if it's a positive. How do we write the ion symbols? Same way, we have the element symbol. But then in the upper right-hand corner, we are going to write plus or minus and then the charge. How do ions affect the properties or sizes? So the size of the atom will change slightly. If it's a positive cation, meow, cat, meow, it's positive. It's going to lose electrons. So the atom is slightly smaller. Negative means we gained electrons. Atom bigger. Properties are impacted. So sodium versus Na+, right? Those are going to be very different properties. Sodium metal that's neutral is very reactive with water. It actually catches on fire, and that would not be good. We know sodium is necessary, and we eat a lot of sodium in our diets. Well, that's actually Na+, the ion. That would not be good if Na+ reacted the same way as Na. In our body, which is mostly water, if this started to explode, we would not last very long as humans, right? So sodium, neutral sodium metal reacts very differently than Na+. Okay, so a couple other things that we need to know. So we can talk about valence electrons later this year. Those are the outermost electrons. So the first column has 1, second column has 2, 3, 4, 5, 6, 7, 8. That's how many outermost electrons. Well, that determines if we're going to gain or lose electrons. So if you notice, here's my metalloid staircase. Metals all over here. Metals are likely to have a positive charge, meaning they lose electrons. So something over here, a +1 charge, means this element right here is likely to have an oxidation number or a charge of +1. It's going to lose an electron. Why? Because it now, instead of being like this, is going to feel up a row like this guy in the third row, which is the goal. Okay, so something in the first column, the alkali metals, when it loses an electron, it becomes +1, and now it's isoelectronic to this guy right here in the third row. They have the same number of electrons. +2 here, they're going to lose 2 electrons, so then he feels like this guy. These guys have variable charge, so what you will see in naming is that the oxidation number will be given to you for those metals in Roman numerals. These guys are likely to share, but just know that it is also possible if this is -1 right here, if these guys are all -1, meaning they gain an electron, so then it feels like this guy. He gains an electron, feels like this guy. These guys will be -2, -3. Again, typically they will share, but it's also common for something like nitrogen, potentially oxygen, to gain 2 electrons or to gain 3 electrons. All right, a little challenge for you. As a Titan, you should be able to write the symbol notation for 2 possible isotopes and 1 common ion charge for each of the 3 elements. And I do give you some hints about maybe to figure out the charge of titanium. Yep. So if you would pause the video, and for Ti, for Ta, and for N, I would like you to write 2 isotope symbols and 1 ion symbol for each. Good luck. So first, let's look at the hint. I'm telling you that TiO2 is a common compound. The reason I'm telling you that is because I don't know the charge of titanium just by looking at it at the periodic table. But I do know ionic compounds are trading electrons, one's giving and one's taking. And I do know that oxygen is always -2. Well, if that 2 went down here, right, that's not what we're seeing. So what I know by looking at this is that the charge of titanium has to be something that would reduce to ending with a 2 here. So that means this has to be +4. So titanium must typically form a oxidation state of +4. So I can do my ion, titanium, and that's 4+. So that means it lost 4 electrons. So there's the ion. Looking at my periodic table, we have 22 as my atomic number. That is not going to change for my 2 isotopes. What is going to change is the number, or the mass number. So I look on my periodic table, I can see that there is a decimal given to me, but remember, mass number is just protons plus neutrons. So I see it's between, it's 47 point something, so that tells me that one isotope is likely to have a mass number of 48 when I add protons plus neutrons, and the other maybe 47, because we know that number for mass on the periodic table is a weighted average of those 2 isotopes. All right, I put up the next one. Feel free to check, and then I'll do the same thing with nitrogen. Nitrogen is likely to gain 3 electrons, 7 protons. I see nitrogen's mass on the periodic table is 14.007, so we know for sure there's probably an isotope at 14. The next one maybe is at 15. So here's my 2 isotopes. There's my ion. Oh, that's my head. There we go. So I hope you guys found this mini lesson helpful. You are going to complete the discussion post related to this video for your points for today. I also wanted to show you talk really quick about our summer assignment quiz. So if you go on Canvas to where it says summer assignment, maybe, let's try that again. All right, so here's all the stuff. First of all, you will be uploading all of your summer assignments right here. And then there's a summer assignment quiz, which we will be taking in class on, whoops, it's always good. We will be taking the quiz, during Zoom on Friday. So I want to give you as much time as possible. So really quick about this quiz. Let's go just to the straight interims. Why did something go wrong? Okay, it's early. It's 5 in the morning. We're just going to move on. But let me talk to you about this quiz. I'm going to pull up on my computer the kind of rules or expectations for the quiz. So you'll have me on one Zoom window, the quiz on another Zoom window. You feel free to watch videos about split screening and then muting my tab so you can't hear me, and you can mute yourself as well, so I can't hear you. But then when you're ready, like if you have a question, you can unmute the tab and unmute me or yourself so you can actually talk. Okay, so for the quiz, couple of things. You are only allowed to, where's assignment checks? You're only allowed to use the periodic table and the equation sheet that I provided at the beginning of the year, those purple pages. You can also use your calculator, but no other notes, no problem sets, nothing else. Why is this not pulling up? Okay, anyways, there is a timer on the quiz. You will see one question at a time, but you are allowed to go back. But just pay attention to that timer. The goal is that we are moving through the quiz, so if you don't know how to solve a question, skip it. And there are several questions where I ask you to upload a picture because I want to see your work. So please make sure you're taking clear photos when you upload. All right? I will see you at Zoom for any last minute questions, but for the most part, I'm going to let you go and take the quiz.